Welcome everybody. We've been given this question 2 raised to the power of 2x squared negative 17 times 2 raised to the power of x squared negative x positive 2 raised to the power of 8 negative 2x is equal to 0. Now you can clearly see that this particular system has got exponential quantities embedded all across. And what we have to do is we need to convert this into a quadratic equation so that we will be able to extract the values, or in other words solve for x. That is the objective. Now foremost, what I wish to do is I would like to multiply both sides by 2 raised to the power of 2x. Now when I do that, therefore the left hand side can be rewritten as 2 raised to the power of 2x squared times 2 raised to the power of 2x negative 17 times 2 raised to the power of x squared negative x positive 2. We are multiplying with 2 raised to the power of 2x followed by 2 raised to the power of 8 negative 2x. We are multiplying by 2 raised to the power of 2x. 0 multiplied by 2 raised to the power of 2x will give us 0. Right now we would like to use this law of exponents. A raised to the power of m multiplied with a raised to the power of n is equal to a raised to the power of m positive n. So if I were to use this is rewritten as 2 raised to the power of 2x squared positive 2x negative 17 times 2 raised to the power of x squared. Now I've got a negative x and a positive 2, so this would also be added, and thereby 2x added with negative x would give us x positive 2, right? Now this is followed by, now if you were to add these two together, you got a negative 2x and a positive 2x, they would get annihilated, giving me 2 raised to the power of 8 is equal to 0. Now what I wish to do is I would like to rewrite this as 2 raised to the power of 2 of x squared positive x, right, followed by negative 17 times, let me place a parenthesis. I don't want to place a dot here because it might be a little bit misleading, so that's the reason I avoided placing a dot in between. So now what I wish to do is I would like to rewrite 2 raised to the power of x squared positive x positive 2 using this same formula. Now what I will do is I will revert back the formula. So I've got a raised to the power of m positive n. I can rewrite it as a raised to the power of m times a raised to the power of n. So this can be rewritten as 2 raised to the power of x squared positive x, that's one term, multiplied with 2 raised to the power of 2, right, followed by 2 raised to the power of 8. Now if you were to multiply 2 raised to the power of 8, in fact 2 multiplied 8 times would give us 2, 5, 6, right? All we are doing is 2 times 2 times 2 times 2 times 2 and so on, goes up to the degree 8, and that would give us 2, 5, 6. Now this is going to be 4 multiplied with 17, and that would give me a value of 68. So let me write this down. So this is going to be 2 raised to the power of 2 of x squared positive x negative 17 times 4 gives me 68. That has to be multiplied with 2 raised to the power of x squared positive x positive 256 is equal to 0. So this is what we have got. So now what we will do is I would like to rewrite this using the law of indices. A raised to the power of m times n can be rewritten as a raised to the power of m, the whole is raised to the power of n. I can always write it like this. So this is going to be rewritten as 2 raised to the power of x squared positive x, this is raised to the power of 2, followed by negative 68 of 2 raised to the power of x squared positive x positive 256 is equal to 0. Now what I wish to do is I would like to make a substitution. Let 2 raised to the power of x squared positive x be equal to sum t. So if I were to take this, as say sum 2, therefore 2 can be rewritten as, in place of 2 raised to the power of x squared positive x, I will be substituting t. So this is going to be t. Now this is raised to the power of 2, so place that, followed by 68. This is going to be t, followed by 256 is equal to 0. Okay, so we got a quadratic system. Now we need to solve this. The question is, how are we going to solve it? Applying quadratic formula, that's it. So if I were to apply the quadratic formula, I would get t is equal to negative of negative 68 is going to be positive 68 plus or minus root of, now this is going to be 68 square negative 4 times of 256. So you got some numeric aptitude to be performed here, divided by 2 times of 1. Now let me just multiply 68 times 68. 68 multiplied with 68, 8 8s are 64, carry 6, 6 8s are 48 and 6 54, 6 8s are 48, 4, 6 times 6 is 36, added with 4 gives me 40. I have a 4 and a 12 and a 6 and a 4. So this is going to be 68 plus or minus root of 4, 6, 2, 4, negative 6 times 4 is 24, and 5 4s are 20, and that 20 you have to add it with 2, so you're getting 22, and 2, 4 2s are 8, 9, 10, so you get 1024 divided by 2. So 4624 minus 1024, what do you get? 0 0, this is going to be 4, and oh, this is going to be 6, not 4. So from 4 you take away 1, you get 3. So you get 3600. So you got 68 plus or minus root of 3600. So that is going to be, let me write that down as 36 times 100, right, divided by 2. Now this can be rewritten as root of a into b is equal to root of a times root of b. So square root of 36 times 100 is equal to root of 36 times root of 100. Root of 36 is 6, and root of 100 is going to be 10. So you got 6 into 10. Fair enough. So 68, you got a positive value, plus 60 divided by 2. This is going to be 128 divided by 2. 64, t is equal to 64 is one value. Then the another value, 68 minus 60 divided by 2 is equal to 8 divided by 2, which is equal to 4. So you got two values, t is equal to 64 and t is equal to 4. But what is t? But my t is taken to be as 2. Let me show you that. This is the value of t, right? So 2 raised to the power of x squared positive x is equal to 4. But I can rewrite this as 2 raised to the power of x squared positive x is equal to 2 squared. Now if a raised to the power of m is equal to a raised to the power of n, if the bases are same, then the indices will be equated. M is equal to n. So this would mean x squared positive x is equal to 2, which in turn means x squared positive x negative 2 is equal to 0. Apply the quadratic, you get negative 1 plus or minus root of 1 negative of negative 4 times 2 positive, right, because of the presence of a negative, divided by 2. So this is negative 1 positive 3 divided by 2, which is 2 over 2 is equal to 1, or negative 1 negative 3 divided by 2, which is negative 4 divided by 2 is negative 2. So therefore x is equal to, what have you got? You got 1 and negative 2. This is for the first value of t. Also, what do you got? We got the value of t to be as 64, right? So t is equal to 64. This means 2 raised to the power of x squared positive x is equal to 64. This means 2 raised to the power of x squared positive x. Now I can write 64 as 2 raised to the power of 6. As I mentioned to you, the bases are the same, so this means x squared positive x is equal to 6, which in turn means x squared positive x minus 6 is equal to 0. So x is equal to negative 1 plus or minus root of 1 negative negative positive. So 24 divided by 2, which is equal to negative 1 plus root of 25 divided by 2. Negative 1 positive 5 divided by 2, which is going to be 4 divided by 2, which is equal to 2. Or negative 1 negative 5 divided by 2, negative 6 divided by 2, which is negative 3. So therefore x is equal to, in fact let me write the negative value first, negative 3 comma 2. So if you were to take the solution set is negative 3, negative 2, positive 1 and 2. So this is actually the values for x for which the system is solved. This is a lovely question and I hope you enjoyed this. Thank you.